Hello friends, welcome to the course of marketing research and analysis second part. So, in the last lecture we were discussing about the N-way ANOVA and we had started with MANOVA, right. So, we said N-way ANOVA is a case where the researcher wants to examine the effect of two types of the effect of a treatment of a any treatment with 2 or 3 levels, right. So, if there is only one, it is a we say one treatment or one factor, then we say one-way ANOVA. If it is more than one factor, that means there are 2-3 kinds of treatments with 2-3 different levels, then we say it is a case of 2 or 3 factor ANOVA, or that way we said it is a N-way ANOVA, right. And there the major advantage is that when you have 2 treatments or 2 factors, the advantage is that it helps you to find out the interaction effect. So, it not only tells you about the absolute model, the overall model, but it also helps you to tell the main effects of the individual factors. The suppose 2 factors are there. So, the individual effect of the first factor, the individual effect of the second factor, and then the interaction effect of the first and the second factor. So, this interaction effect which is possible is a case basically is a case of the factorial design which you have learnt in the experimental research, right. So, that was a case we solved 2 problems, one was in a primary method, the other we solved through a through the formula. And then we started with something a situation where the researcher is not having now one dependent variable, but he has got more than one dependent variable, and the number of independent variables can be 1 or 2, right. If it is 1, then it is okay, it is suppose 2 dependent variables are there and only one independent variable, then we say one-way MANOVA, right. Or there are suppose 2 or more independent variables and 2 or more dependent, 1 or more dependent variable, then we say it is a two-way MANOVA, right. So, MANOVA is a case where now the dependent variables have changed are more than 1, and the independent variables could be only 1 or more than 1, right, depending on whether it is a one-way MANOVA or two-way MANOVA. Okay. So, the assumption we had discussed here in the last lecture was that 2 or more dependent variables should be measured in a interval or ratio level, right. So, these are some of the revision time, exam performance, weight examples. Our independent variables should be 2 or more categorical independent groups, right. So, independent variables could be, for example, I have said physical activity, profession, right, it could be. It is not necessary 2 or more only when you are talking about two-way MANOVA, right, two-way MANOVA. If it is only one, let us say one categorical independent variable, then with several levels, then it is a one-way MANOVA, right, one-way MANOVA. We said during the assumption that there should be independence of observations, which means that there is no relationship between the observation in each group or between the groups. That means different participants in each group with no participant being in more than one group, that is one of the assumptions. Sample size should be adequate. Now, 20 observations for each level. Now, what did I say, or each cell you can say, understand is not cell, level, cell. For example, there are 2 factors and each factor has got let us say 3 levels. So, how many cells are formed? Now, 6 cells are formed. So, each cell multiplied by 20. So, you have 120 should be your sample size, right. So, this is one thing that you need to understand. There should be no univariate or multivariate outliers. Now, that is very important because you have understood from the very beginning that this is a test of means basically, right. So, all kind of T test, Z test, F test, MANOVA, ANOVA you talk about, they follow the means, right. So, if when you follow the the condition of mean, then if there is a presence of outlier, it will completely distort the whole statistical analysis, right. So, you should ensure that there is no outlier. Okay. Next, multivariate normality. Now, normality is an assumption which is very essential for most of the statistical tests, right. If a statistical test, if the data does not follow a normal distribution, then a parametric test is not possible, right, and these are all parametric tests, ANOVA, MANOVA and all. There should be no linear relationship between each pair of dependent variable for each group of the independent variable. That means it says there should be some kind of correlation among the between the dependent and the independent variables, right. So, it says the linear relationship between each pair of dependent variables for each group of the independent variables. So, there should be some relationship, right. Homogeneity of variance, now that is already we have said ki when there are several groups, these groups can only be compared when the groups have a similar kind of variance, right, otherwise they cannot be compared. Multicollinearity is another assumption which is required. Ideally you want your dependent variable to be moderately correlated with each other, but no multicollinearity, that means the independent multicollinearity happens when the independent variables are strongly correlated. So, if they are very strongly correlated, sometimes the meaning happens that there is a redundancy of facts, unnecessary you have used more than suppose there are 3 independent variables out of which 2 are very highly correlated, that means these 2 mean the same. So, you could have used only one of it and not 2, right. Now, how do we conduct this one way ANOVA in SPSS? First let me tell you, right, because one way MANOVA in SPSS, because I had said earlier also MANOVA is very complicated and doing it in hand is hardly beyond the class capacity at the moment, right. So, it cannot be done. So, whatever could be done we have shown it by hand, for example, one way and all we have shown 2 way, but MANOVA is very difficult, it is not possible. So, we will show it to how to do it by SPSS, right, one of the software packages. So, this is a case, this is an example. Let us read this example. Students at a high school come from 3 different primary schools. Okay. The head teacher wanted to know whether there were academic differences between the pupils or the students from these 3 different primary schools. So, that means there are 3 different primary schools, students have come from it, passed out from it. Is there any academic significant difference between this between the students results from passing out from these 3 schools? As such, she selected 20 pupils from school A, 20 from B and 20 from C. So, 20, 20, 20 and measure their academic performance, right. So, in this case if you can see what is the independent variable which is playing important role on the dependent variable. Now, the dependent variable is my score, the student has scored, and which school he is coming from is my independent variable. So, the category is only a categorical variable A, B, C, okay, with 3 levels, right. So, academic performance and measure the academic as measured by the marks, right, marks received for their end of year English and maths exams. So, 2 exams were conducted, English and maths, and what is the scores students from the school A got for English and maths, students for school B got for English and maths, and similarly for C, what did they get, how much they score, right. So, the 2 dependent variables were what, English score and maths score. So, these are my 2 dependent variable, while my independent variable is only school. So, I have only one independent variable. So, if I have only one independent variable, then it is a case of a one way MANOVA, right. So, which consists of 3 categories A, B, C, 3 levels. Okay. Okay. Now, what is when I talk about ANOVA, only ANOVA, it is a comparison of means, but when I talk about MANOVA, right, or 2 way ANOVA, right, ANCOVA. So, here we use a model called the general linear model. Now, what is this general linear model and why it is so much in demand nowadays, why every scientist is talking about this general linear model. It from in the earlier times, research has also evolved, it has improved with time. In the earlier days, when Fisher developed the techniques of ANOVA and all these things in 70, 60, 80 years back, at that time they did not have this advantage with them. They did not know some of the facts, because everything evolves with time, right. So, this is a new model that has developed, which says is a general, the name is general linear model, or if you see softwares you will see GLM, right. What is this GLM? I will explain. It provides the researcher with a single, this is the important thing, single estimation model within which any number of differing statistical models can be accommodated. That means, if different statistical models, for example regression, test of means, they can all be accommodated at the same place in a through a linear equation, right. It is simple and flexible for model design, and it has 3 elements which are very important. What are these 3 elements? So, the first is the variate, right. What is the variate? The linear combination of the independent variables as specified by the researcher. Each independent variable has an estimated weight, right, please remember this, representing that variable's contribution to the predicted value. So, the first element is the variate. Now, each variate is given has an estimated weight which represents how much it is contributing to my dependent variable. Second, random component. This says the probability distribution of the variables is based on the type of my dependent variable in the case of the general linear model. Suppose it is a continuous variable, which in case of MANOVA or ANOVA you are doing, right, then you follow a normal distribution. Suppose you would have had a proportions, you had used proportions, ratio and proportion, right, proportions, then I will use my binomial distribution. The probability distribution would be binomial in nature. But suppose I am using a method like dichotomous, which is yes no kind of. So, then I am using a Poisson distribution. The researcher selects the random component based on what kind of dependent variable he is using. So, general linear model helps you in these 2 things with the third thing. What is the third? What is the link function? Link is the connecting, link means connecting, connection. It provides the theoretical connection between the variate and the random component. It specifies the type of transformation needed. So, you must have seen earlier in my very initial classes, we had talked about transformation of variables. Now, when the variables are not following a particular distribution and we want it to follow, then we try to transform the data, right. So, we use a logarithmic transformation, a square transformation, a cubical transformation, we used various kinds of transformation, inverse transformation. So, here we say this link function helps you to do that. It specifies what kind of transformation is needed to specify the desired model. So, log transformation is a very logit, log and kind of identity. So, these are the kind of transformations you generally talk about. So, general linear model is helping you to create a single model, linear model, which can accommodate several statistical tools, right. How do you do it? When you go to, just to show you, many people might not be aware, so I am showing it. When you go to SPSS, there is see analyze, go to general linear model, and now had you been doing a 2-way ANOVA, suppose this case, then you would have done this is for a 2-way or a n-way ANOVA, this is a n-way ANOVA, right, n-way ANOVA, right. But we are doing a multivariate now. Why? Because we have more than one dependent variable. In this case, what was happening? You had only one dependent variable and more than one independent variable. So, more than one independent variable and only one dependent variable. So, 2 or more you can say independent variable, but in this case we have more than 2 or more dependent variable and 1 or more independent variable. So, this case is a case of a general linear model multivariate condition, right. Okay. So, next what we will do in this case is, in our case example, school was my, what was school? Independent variable. So, school is my independent variable which comes into this category of fixed factor. Now, English score and math score were my dependent variables. So, I will take it here, right. We do not have a case of a covariate. I will explain what is a covariate. I had explained in one of the classes when I said about ANCOVA, but we will do it later on, right. In the next lecture we have ANCOVA, we will explain that. Then once you have done it, right, then you go to the next. So, now you need to profile plots, you check the profile plots. Now, first take the school, right. So, school is my independent variable. So, I am taking it into the horizontal axis, right, and I am continuing. So, after I have done with it, then I am checking for post hoc test. Now, what is this post hoc? There are 2 things in research. See, whenever you have more than two groups, let us say your null hypothesis says ki there is mu A is equal to mu B is equal to mu C. Well, suppose this hypothesis is my null hypothesis, and what is my alternate? At least one of them is different, correct. Now, suppose my alternate has been accepted, my null has been rejected. So, that means what? At least one of them is different. The question that comes to you is which one is different, right. So, to do that we do a post hoc test which compares the means individually with across each other. So, post hoc test out of there are several methods. The most likable method is the Tukey's method. So, the Tukey's method is a and Bonferroni, LSD. So, there are few methods, but Tukey is the most applicable method, right. So, there are two methods as I said, one you have the post hoc, the other is you have also a priori method which is not there here. So, the priori method also tells you to compare before the research is done. So, let us talk about the post hoc only. So, once you have done all this, then you go for the proceed with the steps. Okay. Now, you see, so we have marked Tukey, right, and continue again. Now, we will see the means for what? The school. Why we are checking the means? We want to compare it and we want to see the main effects. So, but here since you have only one independent variable school. So, what is the question of checking main and what is the question of checking the interaction? No interaction is possible, only one school is there. So, had there been school with let us say the type of income group they are coming from. So, two factors, then there an interaction was required. So, here we will only go for descriptive, you see estimates of size, observed power and this one homogeneity, right. So, now again we click on the continue button. Now, how do you report? Let us see. So, this is very important. After this I will show you also a problem on SPSS. How do you report? Now, this is how you will get a table, right. And here if you see the school, this is the independent variable we are talking about. So, there are something called Pillai's trace, Wills lambda, Hoteling's trace, Roy's largest root, out of which this is the one which we generally report in any research publication. Roy's largest root is also good, but it is highly sensitive to normality, the assumptions, basic assumptions of MANOVA, but Wills lambda is more robust. Okay. So, how do you write? Now, if you look at it, it is significant, right. The eta square, now what is this eta square, what does it tell you? The eta square tells you the effect of size, the effect size basically, right. So, the higher it is 0 to 1. So, 1 means very it has a large effect and 0 means absolutely no effect at all, right. So, when you write the research report you should write like this, there was a significant, in this case significant difference in academic performance based on the students or the pupils prior school, right. How did I know? Now, F is equal to 4 and 112. Now, 4 is my numerator, 112 is my denominator, right. So, these are my degrees of freedom is equal to this much, and at P was checked at 0.005, this is 0.05 it should be, not 0.0005, sorry, it should be 0.05 only. Okay. So, just strike 0.05 and Wills lambda is equal to 0.45. So, Wills lambda, let us say where is the Wills lambda, 0.45, right, and eta square is 0.33. So, this is how you write the report, right, for a MANOVA. Why I am telling this is many people are confused, they do the test, but how do you report it, how do you write it, is they are not very clear, right. So, Wills lambda is referred to as the multivariate F and is commonly used for testing overall significance between groups, Roy's greatest characteristics root is also appropriate when the dependent variables are strongly correlated. If the dependent variables are very strongly or moderately correlated or highly correlated on a single dimension, but it gets severely affected by violations of the assumption. The problem is here. Otherwise, if your dependent variables are strongly correlated, then you should go for a Roy's greatest characteristic root, right. Now, what we will do is we will solve a problem on SPSS, right. So, two-way MANOVA, right, MANOVA. So, this is the case, right, we were talking about. So, these are 2 scores and there are 3 schools. So, let us first see and maybe again we will go back to the slide, right. So, first analyze, then I go next to what? I go to general linear model, right. So, what will I go? Will I go to an univariate or multivariate? I will go for multivariate. Why? Because we have a case of MANOVA where there are more than one dependent variable. Okay. So, which is my fixed factor or my independent variable? The factor. You remember this, fixed factor means we are talking about the factors, the treatments basically. So, what treatment is there? The school is the treatment in this case. Okay. Maths is my dependent variable, English is my dependent variable. So, the score of maths and English depends on which school does the student come from. Okay. Now, I will go to plots as I had shown you there and I add, right, continue. Post hoc, I want to compare obviously between the 3 schools A, B, C and which one is the best out of it. Okay. Then I go to options and I go to schools, display means for schools. See, this is not coming, why? Because the point is you the interaction effect is not required here, only the main effect of school will be shown to you, nothing else, right. So, what you do is you take the estimates of effect size, the eta square, which is what you say is the eta here, homogeneity and observed power of the test, right. What is the significance level? You may change it if you want, but here it is only 5%. Now, let us run it. So, when I am doing it, I have 3 schools, 15, 15, 15 candidates each. The question is, should we have 15? But I should have more, right, because there are 3 levels and I only said beforehand that there should be 20 per each cell. So, there are 3 levels, so it should be at least 60, but I have only 15. So, this is not adequate, but just understand that this is for a class, this is to run this SPSS tutorial I am showing you, but when you do it, ensure that for each level you have 20 cases. So, there are 60 cases at least it should be there. So, maths you see 1, 2, 3. So, what is the school 1? The maths average 64, 74, 64, 64, overall average 67, English 67, 69, 65. Now, what is this box test of equality of covariance? This as it says, if you can see, test the null hypothesis that the observed covariance matrices of the dependent variables are equal across groups. So, basically the box test, it tells you about the equality of the groups, whether there is significant difference or the groups are similar in nature. So, it is basically significant means the null hypothesis is rejected, that means there is a significant difference among the groups. This is a very powerful test, this is always to be, it should be reported also in your research paper, right. Now, coming to the effect multivariate test, now we are interested for this part, right. So, let us go to the Wills lambda. What is the value? 0.503. What is my F value? 8.404. What is my degree of freedom? 4, and what is my significance? The significance is 0.000, and what is my effect size? 0.291, and what is my observed power? 0.998, right. So, and it has been tested at 0.05, right. So, first of all let us see the 2 dependent variables maths and English. Actually in this case somehow the data what we have used, because I have already said the adequate data was also not there, it was only 45 where it would have been 60. So, it is coming, if you see both are significant, right, but actually our hypothesis is that Levin's test, which talks about the homogeneity of variance across the groups, should be actually the null hypothesis should be accepted, well there is a all the groups have equal variance, but in this case that hypothesis is getting rejected. So, when you write, you kindly write this in your report that in this in our study the error variance, the groups across the variance across the groups was not same or equal, right. Now, coming to the test, right, between subjects. Now, if you look at the school, right, maths, English, what type 3 sum of squares is basically the Pearson sum of squares, right. So, what is the finding? So, significant school maths score, there is a significant difference in the maths score among the 3 schools, right. There is also a significant difference in the English score among the 3 schools, right. But if you see the effect size is more in case of for maths than in comparison for English, and the observed power, that means the power of the test is much higher for maths, that means the difference in the maths score is more clearly evident than in comparison to the score for English among these 3 schools, the students of the marks of the students of the 3 schools, right. So, basically this is what we want to mention, and then we will see a multiple comparison, right. So, let us see, is there any difference? Yeah, school 1 versus school 2, the mean difference 9.67, is it significant? Yes. For this is only for maths, 1 and 3, yes, there is significant difference. So, 1 and 2, 1 and 3 is done. So, 2 and 3 is left. 2 and 3, is it different? No. So, the math score for the students of school 2 and school 3, we cannot say it is different, right. Now, coming to the same thing, if you go right. Now, coming to the English score between school 1st and school 2, is there any significant difference? No. 1 and 3, no. 2 and 3, yes, right. So, if you see, this study says ki, well, in this case if you look at the mean also, so I minus j, that means what, I minus j, that is I is this one, j. So, 1 minus 2 is 9.67, that means school 1 is higher than school 2, school 1 is higher than school 3 also. So, school 1 has got the highest score and it is significantly different from the rest, right. But 2 and 3, if you see the difference between 2 and 3, so what is the difference? Only 0.47, where 3 is higher than 2, right, and that is not significant obviously. So, this applies same to 1 and 2, and in this case in English the school difference of 1 and 2 is 2 has a higher marks in English than school 1, and 1 and 3 if you compare, yes, 1 is higher than 3. So, 2 is the highest, then I think 1, then 3. So, this is all what you can find out from the case of MANOVA, right. So, today what we have done is we have understood the multiple analysis of variance, right, in which I have explained what a MANOVA means and when it is to be used. MANOVA is a technique which is a part of the experimental design and very highly used by researchers both in the pure science, the engineering, medical, pure science, basic science, or even in the psychological labs. So, here the researcher can determine the effect of an independent variable, one or more, on several dependent variables, right, and then can see the effect of these, which earlier we did not have a we could not do it, right, in other tests. So, that is what MANOVA has a great advantage. So, I hope this class must have given you some insight, and even I explained how to write the report, the findings in a research of the research work, right. So, I am sure this class must have been of some value to you. You must have been slightly clear ki what MANOVA is and how MANOVA is to be written and how it is to be utilized, and the more you use it, I think you will get clearer and clearer. So, this is a basic understanding that I have tried to give you. Thank you very much and all the best.